10.3, example 7. In this example, we're going to find the area of the smaller loop of the limicon r equals 2 cosine theta plus 1. So in this example, we're going to get a limicon that has a loop in it, and we're going to want to go ahead and find the area of the smaller loop. Okay, so just like in the last example, step 1 is going to be to graph it. So I'm going to go ahead and graph it now, and I'm going to trace out the graph. So it loads, and it looks like there's my loop that's being made as we go from 0 to 2 pi. So here is my limicon, and my goal is to get the area of the small inside curve. So if I were to graph that completely, it looks like this, and I want the non-shaded area in this example. All right, so my goal here is to get this area inside here. And so to do that, when you want to integrate polar functions, all you need to do is identify where theta starts and where theta is going to end. So just for good practice, let's go ahead and we're going to try to find the value of theta right here. Because the curve comes down like this, keeps going around, and then comes back to that dot again and then keeps going. So I need to find the coordinates of this spot here. So notice right here on this, where this dot is, that the y value of a coordinate, if I use it as an xy coordinate, would equal 0. So what I can do is I can set y equal to 0. So let's go ahead and do that. Remember that y is given by r times sine of theta. So then y is equal to 2 cosine of theta plus 1 times sine of theta. So all I have to do now is set that equal to 0. And then I go ahead and solve each. So I get cosine of theta is equal to negative 1/2. And sine of theta is equal to 0. So here I get that theta is equal to 2 pi over 3 and 4 pi over 3. And here I get theta is equal to 0, pi, and 2 pi. So step 2 is to identify which theta values you want to use. So I know that my theta values are going to be 0, 2 pi over 3, pi, 4 pi over 3, and 2 pi. And if I look at my graph, they have to go in order. So this point right here is going to be where it starts. This is the point 3, 0, right, where this is theta. The next point where it's 0, if I follow the graph, if I'm tracing it, if I'm tracing the graph out, the next point where it's 0 happens right here. So then that would be 2 pi over 3. And then if I keep tracing out this graph, this is the next place at 0. So then this has to be 1, pi. If I keep tracing out the graph, I get the next point where it's 0. So this has to be 0, 4 pi over 3. And then if I continue tracing the graph, I get here, which again will yield 3, 2 pi. So the two pieces that I'm looking for are going to be 0, 2 pi over 3 and 0, 4 pi over 3, because that closes this inner loop. So then step 3 is to set up the integral. So I have 1/2 the integral alpha to beta of f of theta squared d theta. So it's going to be 1/2. My alpha is going to be 2 pi over 3, and my beta is going to be 4 pi over 3, and my function, which is r, is going to be 2 cosine of theta plus 1, and then I square it. And again, we need to be able to do this kind of thing by hand. And after integrating all of that by hand, you get this nice little clean answer, which just turns out to be some crazy decimal. But that's it. It's just the integrating, I think, is the hard part, and setting it up initially. For most of these examples, you probably will need a double angle formula dealing with cosine or sine.